So hello everyone, this is Monica Anderson from Software Toolbox. I'm standing in for Bob Lowe, CSIA Executive Director who is at a partner event this week. Thank you for attending the March CSIA webinar. Today's webinar will provide up-to-date information on the latest cybersecurity issues and their impact on your company and your client business also. Be sure to ask questions in the Q&A box, not the chat box. The host and sponsor of our monthly webinar is Software Toolbox, a CSIA partner member. Software Toolbox helps sister Integrator lower their risk on projects that involve software by providing them a unique mix of off-the-shelf software products and rapid response technical support that minimize the needs for custom codes and lower field startup time risk. I would like to introduce today's webinar presenter, Eric Beyer. Eric is recognized as one of the world's leader experts in the field of SCADA and control system security. Eric's background as a process controls engineer allows him to bring a unique combination of deep technology knowledge plus practical field experience to his role as CTO and Vice President of Engineering of Tofino Security, a Belgian brand. Eric has provided security guidance to government agencies, major oil companies, and power utilities on security protection for critical infrastructures. Eric has researched and written extensively about Stuxnet and is chair of ISA 99 Task Group 2, conducting an analysis of ISA 99 stands for respect to Stuxnet. So, without any further delay, here is Eric.
Thank you very much, Monica, and welcome all of you. And hope you enjoy today's talk. We'll be doing Q&A throughout the talk today, as Monica mentioned. Please enter, if you want to type in your questions, enter it into the Q&A box, not the chat box. We'll also be doing some opportunities for live Q&A if you just want to ask me questions. We'll be doing a couple of breaks to take questions. But to start off with, I'm going to tell you something that you all know, and that's the world of automation is changing. And back when I was a young process engineer, there were a lot of islands of automation, and those are pretty much gone now. Things are very, very interconnected. You don't have little data highway networks that don't talk to anything or talk to other systems at great expense. Instead, you have a lot of common protocols like TCP/IP, Ethernet, and HTTP. To mention a few, they're flying around our control systems and interconnecting our control systems into other systems, ranging from maintenance management and asset management systems to lab systems to corporate systems, data historians. I think all of you know just how interconnected our control systems have become and how interconnected the systems you design are. But at the same time, there's also another item in the mix, and that's some new threats and some new actors in the game. And it really all started well, it started a long time ago, but it really came to prominence and the game changed a few years ago in July of 2010 when the Stuxnet worm was discovered. Now, if you're not familiar with Stuxnet, it's something you should be aware of, but it was discovered attacking Siemens PLCs, WinCC systems, and their whole PCS7 systems around the world. And prior to that, most of the worms that we had seen out there were worms designed to go after IT systems that had accidentally stumbled onto a control system and caused havoc. So the control systems have been collateral damage. But as people started to study the Stuxnet worm, it became very evident that it was not collateral damage to a control system. It was a worm designed to destroy a control system. It infected about 100,000 computers. As worms go, that's not a lot, but considering most of those were control system computers, that is a lot. It infected at least 22 manufacturing sites. That's Siemens comments. I'm quite certain that it is considerably more because I'm aware of a large number of sites personally that were infected in North America. And it seems to have gone after one thing. It was designed to go after the Natanz nuclear enrichment facility in Iran, and its intent was to modify the PLC logic and the drive logic on the uranium centrifuges in Natanz and literally spin them to death and make them fail. So here's a worm that is not trying to steal data. It is not trying to shut something down. It is trying to destroy a process. And so a very, very different worm than we've ever seen before, and it really has changed the whole landscape. Now, because it was so focused, a lot of people said, well, no big deal. But in fact, actually, for a number of companies in North America, it was a big deal. One large manufacturing plant in the U.S. Appears to have been infected by 2 USB keys coming from outside the plant. Stuxnet infected over 100 WinCC human-machine interfaces on that project site, or on that site. 60 OPs and about 45 S7 PLCs were impacted. It wasn't the target. Again, this was collateral damage. I was pretty sure Natanz was the target. But the impact to the company was expensive. It was a major resource drain for over a month, with all the maintenance staff solely focusing in trying to clean this thing up. All other maintenance efforts ground to a halt, and basically it cost them in the hundreds of thousands of dollars to clean up. So as you can see, you don't have to be the target of something like Stuxnet, and it can still impact a company. And this is important because your clients are now becoming aware of this. Now, one of the things that was really interesting about Stuxnet is it spread very quietly but very aggressively. It was most famous for infecting a system via USB flash drive, and that's what the IT world, all the media and all the politicians jumped onto. Oh, wow, if you have a USB key and it has Stuxnet on it, you don't have to click on anything. You just plug it into a computer and that computer is infected. It would also infect via portable hard disks as well. Now, based on our studies, we believe that that USB key was only used, that spreading mechanism was only one of 7 different ones that actually Stuxnet had. It was a regular Swiss Army knife of a worm. And if you didn't use USB keys, it would find another way around. For example, once it got onto any computer in a network, it would then start to spread over the local area network. If you had shares, any administrative shares between computers, it would use that. It would use network drives, any shared network drives. Very interesting one is it would use print spooler services. If multiple computers shared a printer and a print server, it would send itself as a print job to that print server. And when that print job executed, it would actually infect the print server with Stuxnet, the worm. It also used SQL connections that are the basis for the HMIs in a Siemens system. But the thing that was probably the most scary to me, and the thing that the spreading mechanism that would impact a systems integrator more than anything else, was that it would actually infect you or infect your site via the project files. In other words, as a systems integrator, if you had Stuxnet in your offices and you built a project that included Step 7 ladder logic or Step 7 PLC logic, embedded in the middle of that logic would be Stuxnet itself. And that seems almost impossible to believe. But yes, when you go and actually look at the logic, embedded in the actual files would be the full-blown Stuxnet worm. And so you can see that even doing something like bringing a CD on site with new ladder logic or new programming logic could be a vector to infect a client. And now, it had so many pathways to its victims. It had so many ways to get in that you'll see that it really, if you tried to block it in one way, it would find another way in. For example, USB drives. Well, if you banned USB drives in your plant, then it could use those S7 project files coming in on say a laptop or on a CD or an infected drive. Once it got into a plant, again, it could spread by so many different ways over the network. So there's some real lessons to be learned from Stuxnet. First of all, it really taught us that any modern industrial control system or SCADA system is very complex. It's highly interconnected in ways we don't normally think of. We just chase the network connections, the Ethernet connections. We say, oh, there's the Ethernet connection up to the business network, and okay, that's it. But in reality, it turns out there's lots of other pathways from the outside into a process controllers that we don't think of, such as how do we get our logic into the controllers, how do we get our antivirus updates in, and so on. And so if we think that we can completely isolate our networks and have a complete separation between the corporate network and our industrial control systems, we're kidding ourselves. And I'll talk more about that in a second. And the other lesson that I think particularly important for the systems integrator is that if you just focus on one pathway, for example, USB storage drives or a firewall between your enterprise and your industrial control system, you've made a terrible mistake, because as Stuxnet showed, the well-designed worm won't just have one way in. It'll have 5 or 6 ways in. Now, while Stuxnet was a lesson to those of us in the industrial control world, it was also a lesson to the bad guys. It became the cookbook, the hacking for dummies for control systems. And it spawned a whole new generation of attacks called advanced persistent threats. Advanced persistent threats existed prior to Stuxnet, largely launched against the banking industry. And they're low and slow attacks. They're designed to be very subtle. They're designed to not make a lot of noise and just sit, basically a sleeper attack, and sit on a system inside a company, often used for stealing information. Now, unfortunately for our customers, particularly anybody in the energy sector, we've seen a bunch of these start to get focused specifically on the industrial market. Flame is a famous one, largely infected systems in the Middle East, probably written by the same people who wrote Stuxnet. But Flame, among the other things that it had a fondness for, was AutoCAD drawings. This is not well known, but it particularly hunted out and looked for and sent off AutoCAD drawings. My personal belief is it was an intelligence gathering system designed to get information so that more Stuxnets could be built. There's other worms, though, that weren't made by the same people, and other attacks that weren't made by the same people as Flame and Stuxnet. One is Nitro, an attack that was specifically targeted at the North American chemical industry. It appeared to be designed to steal secrets in facilities, production secrets from facilities that made advanced materials and advanced chemicals. Night Dragon, which is an attack that went after the oil and gas industry, largely targeting production information and bid information, obviously used for economic purposes. And one that was definitely not advanced nor persistent, but loud and noisy, was Shamoon, an attack that went after the company you see pictured here, Saudi Aramco. And it was a worm that was designed to destroy stuff. It destroyed over 30,000, yes, not 3,000, 30,000 computers in about 24 hours at the Saudi Aramco facilities. Saudi Aramco claims that there was no damage done to the control systems, and this may be true, but the amount of damage that was done was quite substantial. And interestingly enough, Saudi Aramco is now investing in a massive protection program for their control systems. It was launched by what appears to be a bunch of amateurs, probably students. They called themselves the Cutting Sword of Justice, and it was a Islamic fundamentalist student group designed specifically to go after the oil interests in the Middle East. So you can see that suddenly not only did we learn a little bit about how to attack control systems, but so did the bad guys. But it's not just the bad guys that are a little bit more aware of control systems, but also a whole class of people that are sort of what we call maybe gray hats, or they call themselves security researchers. And these are people that look for vulnerabilities in a product, whether it's Windows or Adobe or your favorite PLC, and then discover these vulnerabilities and then either sell these vulnerabilities on the open market to the highest bidder, or they just publish them for the notoriety. Now, prior to the discovery of Stuxnet in 2010, the U.S. government tracks security vulnerabilities for control systems. They have an organization called the Industrial Control Systems Computer Emergency Response Team, or ICS CERT. And prior to Stuxnet, there have been 5 security vulnerabilities released, 3 vendors. So that's not very many in all the control systems out there. The year following Stuxnet, there were 215 disclosed vulnerabilities, 104 security advisories, and 39 vendors involved. And what started to happen is that these security researchers were discovering that Windows was a tough thing to crack and make a living on, but your average control system was a sitting duck. It wasn't hardened, it wasn't designed for security, and so that if you went after a product like a major brand of PLC, or even better, if you downloaded a copy of an HMI product and demo version and played with it, you could find all sorts of holes like hidden backdoor passwords, bad handling of licensing that allows somebody to take over an HMI, bad handling of messages that get to the PLC, allowing you to crash or take over the PLC. So lots and lots of these vulnerabilities. Probably the low light, I would describe it, of the whole thing was an event that happened in 2012 called the S4 conference. And in January 2012, they disclosed a large number of vulnerabilities publicly. This is a picture you can see from that event. They not only did they disclose those vulnerabilities, but they did it without informing the vendors. And then they also gave away free attack tools. And this would allow anybody who wanted to be able to take advantage of those flaws. And as it turns out right now, about 40% of the disclosed vulnerabilities that are out there for control systems include working attack code. In other words, you can just go through the lists of these vulnerabilities, find a vendor that you think your victim uses. Maybe your victim uses Allen Bradley. You decide you want to go after that company. Then you just have to get those vulnerabilities. You just have to get the code. And a lot of your heavy lifting, if you have evil intent, is done. I should also mention that if you don't want to do all the heavy lifting, you can go to Russia, sign up on a site by a company called GLEG and buy the Agora SCADA pack. And the Agora SCADA pack for $2,500 US will give you all the attack code you need for, I think it's about 150 different control systems out there. So you can see that this is a major problem that we're now facing, is that not only do the bad guys know that control systems are out there, but they also have the tools to do the dirty work. So at this point, before we go to this next section, I want to see if there's any questions out there on the floor. And so if you have questions, I'll open it up to the floor. We'll also take questions that are typed in.
Eric, I'm going to go ahead and, the one who's called in, I'm going to go ahead and unmute you. And if you do have any questions, please go ahead.
Okay, well, we'll just wait for a second here, see if there's any questions. All right. Okay, well, there's going to be lots of opportunities for questions later. So let's go back to the regular session, and then you'll be getting another opportunity in about 15 minutes. We'll have another questions period. And of course, if you've got a question, you don't have to wait. You can just type it in and send it to me, and I'll see it come up, and I can answer it. So if you don't want to be live on the audio, please do feel free to type into the Q&A box.
I do have it. I have a couple of questions here.
Oh, perfect. All right.
I have from Brett, can we find a list of all 39 vendors with disclosed vulnerabilities and advised? I'm going to paste this.
Yes, you can.
Okay, here you go.
Yes. So I'll just repeat that question. Is there a list of, is there a way to find all those 39 vendors and their products? Yes, there is. Now, that's just the U.S. government list, and you can go to the ICS-cert. In fact, I'm just going to go back one slide so everybody can see this. If you go to the site that's the ICS-cert, and you can type that in, you'll go to a list of vulnerability notices. And in that, they have a way of searching for your favorite vendor. You go down to, I think it's historical records or something like that. It's a little bit of digging around on the site. It doesn't pop up. And then you can look up the vendor of your choice. Now, I noticed somebody else just mentioned that there are some manufacturers that are not on the list, and that is correct. The list isn't 100% complete. The stats that I have, I do have some stats on missing vendors from the lists. I think that the list is a good starting point. I think there's about 70 vulnerabilities that have not been included for one reason or another. Another place that you can go look is through a site by a very, very good controls engineer named Joel Langle, who has a site called SCADA Hacker, and he also keeps a very, very good list for controls engineers.
That have any sort
Oh, I hear somebody out there. Just speak a little louder. Yep. Oh, you're fading out. Did you have a question there?
Bring in your meat logs.
Okay, I think I'm not hearing. Any other questions out there, Monica?
I don't have anyone coming in the chat, so if you want to keep on going with your presentation, I'm going to mute the phone again, and we're going to open up it later.
All right. Okay. So let's carry on here. So what are we going to do about this? You know, what we've seen is that suddenly the bad guys have the motivation, they have the knowledge, they even have the tools, and they're using them. So this is a very serious concern to me, and it should be a concern to you because you're building these control systems for your clients, and they're going to have some expectations that their control system that you've designed for them doesn't break and doesn't get hacked. Well, let me start by telling you what I believe doesn't work after seeing many, many, many sites. And it's really two things that don't work well at all. They're both based on what is known as the perimeter model of security. And it's very popular to sit there and install a firewall between the business and the control network and then just stop there. That's very easy to do. It does very, very little for you. And the reason is it's based on a model called the perimeter model or the bastion model that's been widely discredited. It's a single point of failure. As you know, in any control system or any system at all, if you have a single point of failure, then Murphy's Law will kick in and it will fail. And it's been a failure not just in control systems, not just in cybersecurity, but really in the military world as well. And two great examples are the Great Wall of China and the Maginot Line, where people tried to build a wall to separate the other guys from them, and the other guys just simply went around. Maginot Line being a very famous case where in the Second World War, or before the Second World War, Hitler parked its Panzers divisions in front of this wall of fortresses in front, separating Germany and France, and drove around. So we've seen many, many, many examples, and if you read military histories, or if you are a military strategy buff, you'll see that the perimeter model or the bastion model is not a good model. Now, but it's very attractive because you can imagine that you just have to do one thing, put that firewall in, and then you've defined the inside friendly world and the outside evil world. Now, an even more insidious and dangerous model is called the air gap. And the air gap is where you say, well, I'm not even going to put a firewall in. I'm just going to actually put a physical gap between the control network and the business network. So I'll have my business network, I'll have my control network, and absolutely nothing in between. It's very attractive because obviously digital information can't cross a physical gap. And if no digital information can get across that physical gap, then bad things don't get into the control system. But as Stuxnet showed us, that there's a lot more pathways onto the plant floor than just going from the corporate network into the plant floor network through a firewall. And in fact, there are many, many ways that we've watched systems get infected, from bad modems, bad wireless, bad remote support, infected USB keys, infected PLC logic. Even serial lines can be a way to attack a system. So just cutting off the inside versus the outside is a really unsuccessful mechanism for actually securing your plant floor. In fact, the U.S. Department of Homeland Security gave testimony to the U.S. Congress a few years ago, and this is what they said. In our experience of conducting hundreds of vulnerability assessments in the private sector, in no case have we ever found the operations network, the SCADA system, or the energy management system separated from the enterprise network. The second part was a real whopper. On average, we see 11 direct connections between these networks. This is Sean McGurk, who was the director of the Control System Security Division at Department of Homeland Security. He went on to say that in some networks they found as many as 250 connections between the plant floor or the automation system up into the business network. And I've seen exactly the same thing happen. I was in a large facility in the Texas region, southern Texas region, a few years ago, where they showed me their firewall that they put in and were very proud of it and said that's the only way you can get onto the plant floor. And working with their team, we did a little audit of that statement, and within a week we'd found 17 ways to get in. Some of them were not too dangerous, but were there and were potential threats, such as serial links. Others were laptops that were carried from up into the business network down onto the plant floor without any checks. Others were computers with dual network interface card called dual NICs. Very, very common, where you'll see one computer, two network cards. Absolutely every hacker's dream. You find a dual NIC machine, and I found you a way into a plant floor. So this is really not acceptable, and the U.S. government has, and a lot of industry groups have started to work on this to try and find ways to help industry or mandate industry or demand from industry that changes be made. And here's a few examples. I'll be talking about these more at the CSIA conference in St. Petersburg in May. I don't have time to go through them all, but there's a few that you can look at here, and you will be able to download these slides later so you can review them, or you can go to my website and look up many of these. There's a few others as well. This is industry-specific guidance from different organizations. Some of them, such as the NERC SIP, are absolutely mandatory to understand if you plan to work in the power industry. Same with the American Chemical Council. Very important that you understand these. And I don't know, it looks like we might have lost a slide somewhere here. There's one that I really, really wanted to show you. There we go. Probably the most important, particularly if you do any international work, are the standards bodies, because they will have impact across not just North America, but internationally as well. And they're really going to be the measure that companies are held against, as are they following the current best practice. The one that I highly recommend people look at in North America is the ISA 62443. It was called ISA 99 previously. Now it's 62443. And its companion standards in the IEC called 62443 as well. These are equivalent. There's also the International Instrument Users Association out of the Netherlands. That will eventually become also an IEC 62443 standard. And certification for the actual devices is being put together by an organization called ISA Secure. If you're going to start anywhere, start here, particularly the 62443 standards, whether you get them from ISA or IEC. This is really the goal that you're going to be held accountable to by your clientele. Now, of course, it's not just standards. It's not just government regulations. It's not just industry-specific guidance that you're going to be follow. Many of you might have heard in February that the President Obama issued an executive order on cybersecurity, and it established a voluntary program to support cybersecurity framework or standards called the Cybersecurity Framework. And this is to try and get a standardization of the standards, or a normalization of the standards across North America, across the U.S., particularly for critical infrastructures. What's a critical infrastructure? Well, that's still up for grabs, and the Department of Homeland Security is going to be looking using a risk-based approach. But as a systems integrator, unless your plant and your customers only make dog food, you're probably going to be impacted. Certainly if you're involved in the water industry, the transportation industry, the oil and gas and chemicals industry, or the power PT&D industries, those will be classified as critical infrastructures, and they will have to follow the cybersecurity framework. Again, it's largely voluntary. However, the executive order does allow agencies to add supplemental materials and identify authority necessary to enhance the infrastructure or use their existing authority to regulate. The more sophisticated companies are trying to get ahead of this. I just spent last week with a large oil company. They are absolutely trying to make sure that they have something that exceeds what the executive order is going to expect in place so that they don't get regulated, so that they can stay in control of their plants and their processes rather than being told to do things. So if you're a system integrator in any of those potentially critical industries, you're going to have to know this, or you're going to be putting your company, your clientele at risk of being legislated in ways they don't want to. Okay, let's take another short break and see if there's any questions here. If you want to either enter in any questions, or if you want to ask them, we'll take the phones off mute now, and you can jump in with your questions.
I think I gave the booklet back to Ryan. Unless I mistyped it somehow.
Uh-oh, I think we got a few people just chatting out there. Uh-oh.
We do.
I have a question.
Yes, go ahead.
Some of the firewall products on the market, they use USB keys to download configuration to them. Is that secure?
Yes, it can be secure or it can be insecure. In fact, the product that we make, which is the Tofino firewall, uses a USB key. It's important not to shoot the messenger, and USB keys are just a transport mechanism, like Ethernet, like serial, like everything else. You can do a really rotten job of securing it, or you can do a good job of securing it. So, for example, we did a lot of research, and it was backed up by tests by government agencies on how to use the USB key safely. So it's really important not to say, just let's ban USB keys. And for example, what we do, and a number of vendors do, is we make sure that all the content of the USB key is actually encrypted, first of all. It's also signed, which makes sure it can't be tampered with. And then, uh-oh, I think we better mute the phone here for a second here. And then we make sure that the firewalls themselves, if they see anything that doesn't look good, for example, if somebody's plugged in their iPhone into the USB port, they'll actually disable the driver. So to answer your question, USB keys can be both good or bad. Everything can be good or bad and be misused. So it really is up to the products and the companies to make sure that they do a good job. Any other questions out there? Anybody else? Great question, by the way. Thank you. Okay. There's a question that just got typed in that, thank you very much, Jason. Is this stuff on the radar of the major antivirus software vendors? The answer is absolutely. However, what they've realized is that antivirus software probably isn't going to be the way forward. You can't, buy antivirus for PLC5 or ControlLogix or Quantum. You're just not going to be able to stick an antivirus package right on an industrial controller. In fact, you may or may not be able to do antivirus on some platforms on the plant floor that are even servers. Usually you can. The other issue with the antivirus itself is that antivirus tends to go after yesterday's news. I highly recommend people use antivirus, but Stuxnet got a free run for a year before anybody had an antivirus signature because simply nobody knew to write an antivirus signature. So when you look at the major companies, and a good example is McAfee, a very, very aggressive program to find alternative technologies to secure the plant floor. And a good example is whitelisting, where instead of looking for what's bad on your computer, you look for what's good and make sure that anything that isn't on the good list doesn't run. So we're seeing a lot of work in this area. Our company, which is part of Belden, builds specialty firewalls for the plant floor. These are designed specifically to deal with the protocols that you'd expect to see. So there's a real activity in this area. By the way, what I mean by the protocols you expect to see on the plant floor would be things like Modbus or Ethernet IP or OPC. You don't want to be using something that is intended for the IT world because the protocols you see in the IT world shouldn't be the same as the protocols you see on the plant floor. I often say there's no point in looking for malware in your emails on the plant floor because if you have emails on your plant floor, you've got a bigger problem than just malware. There's another great question here from Brian. Have you seen any sign that the OEMs may shift to a whitelist approach to security? And the answer is you bet. Honeywell, Yokogawa, Schneider, to mention a few, all are either have adopted or are currently looking at adopting whitelist technologies for putting in all the Windows Intel style platforms. So far, the actual controllers are a bit of a challenge. We're working with a number of the vendors to also create a network whitelist. In other words, so that the traffic on the network is exactly what it should be and nothing more. And if somebody plugs in, say, a laptop, a contractor plugs in a laptop in a system and tries to use protocols that are not approved on the plant floor, it immediately gets detected and blocked. And I have another question. In lieu of an air gap between the corporate and control nets in situations where these networks must be connected, what are your thoughts on the use of unidirectional diode technology? Good question. I think unidirectional diodes, in other words, also known as data diodes, which are systems that only allow traffic to go one way, have a place. However, because they will allow you to just set up your traffic controls to go out. I see them used effectively in the nuclear industry. The downside with them, and one that I've also run into personally, trying to deploy them for a client a few years ago, was that often you have to bring information back into your plant floor. It's not so simple as just to say I only want information out. You need to bring in your recipes. You need to bring in your antivirus signatures. You need to bring in new logic. You need to have your lab system connected. You need your vibration monitoring system connected. And as soon as you do that, then you've defeated the purpose. And I truly believe that on your average control system, the hunger and need for data coming in really means what you need to be doing is breaking your plant floor down into control areas, so that, or what's called zones in the ISA model, so that you can segregate and control the traffic coming in. And again, the suggestion earlier, really building a white list of valid traffic coming into the plant floor. All right, I think we better keep going, and we'll take more questions in a little while. All right. Okay. Boy, I'm getting lots of questions now. Okay. All right, so this talk is for systems integrators, and so I wanted to talk about what you're going to be seeing. I'll talk more about this, again, at the CSIA event, but I thought this was really important. So first few expectations are pretty simple. One of the expectations that I think all companies are going to start to expect is that you don't infect their control systems through bad staff practices. Poor USB handling, poor laptop security handling, poor remote access management practices, or poor staff training. If you do any of those things, you're likely to find yourself and your company no longer welcome on your client's site. And that is clearly not the object of the exercise. As systems integrators, the industry needs you. They need you doing the work. But as I mentioned, I was at an internal meeting of one of the major oil companies, and they talked about their systems integrators, and there was a presentation about trying to manage systems integrators, and there were a number of war stories that were really unfortunate about systems integrators bringing in laptops that had not been properly scanned, and these, fortunately in this company, discovering them before that they could infect the plant floor. We've also seen factory acceptance test systems get infected by malware, and then that factory acceptance test system being moved into operation by the systems integrator without getting cleaned up. These sort of things are really serious liabilities for a control systems integrator. Also, the other expectations is that the systems integrator will know the current security standards like the ISA, IEC 62443, and the standards that are relevant to a particular industry like NERC SIP if you're working in the power industry. If you don't know these, then you're really going to be behind the 8 ball when it comes to dealing with your client. There's also the responsibilities. As what we're seeing right now with things like the WIB standards, clear statements of responsibility that the systems integrator not be designing or installing in a secure system, a control system that is not properly designed, and certainly not making an existing system less secure through upgrades and changes. So one of the things that we have seen as well is Microsoft, for example, makes a product called Attack Surface Analyzer, and it's a very useful tool. You run it when a system is first configured, or even better, run it even right out of the box when you get your Windows machine. You run it on that, and it shows you if there's any poor user accounts with bad passwords, whether policies are incorrect. Basically goes through a list of how tough that machine is. And then you let your systems integrators, you let your team, you get people as a project gets commissioned, and you let them work on your systems, which is of course what's going to happen. People are going to be loading necessary software onto those. And then you go back and you run Attack Analyzer or Attack Surface Analyzer later, and you see how much more vulnerable that machine is. And clearly we've seen cases where the machines have become so vulnerable to attack due to bad account management practices. And again, clients are not going to accept this as they start to know, and they're going to have mechanisms to measure whether you've left machines in a better state than when you found them. You're going to be responsible for certain security practice requirements as defined in the standards that apply to the industry you're working in. And particularly if you're working in something like NERC SIP, there's record-keeping requirements that are expected of all the participants in a process control system, including the systems integrators. So you're going to want to know what those are so that you aren't asked later and then scramble. Now, that's the bad news. You've just got a whole lot more work. But there's also a lot of opportunities. Again, I'll talk about these more at the event in St. Petersburg. But the typical control system analysis goes through a multi-step process. I've divided into 5 steps. But most people agree there's an assessment phase that starts off, and there's lots of opportunity for a control systems integrator. Now, of course, you can do audits for risk and threat analysis. That may be more than you want to bite off in the beginning. If you have never done a control system security analysis or audit, you may not want to touch that. But you don't have to do all the heavy lifting. Often these just involve very, very simple projects that are very, very, very profitable. For example, asset inventories or network and communications reviews that don't require detailed knowledge of security analysis, but do require the ability to accurately map and understand what's happening on the plant floor. So, for example, back when I was doing audits like this nearly 10 years ago, we had a very, very small team, and we were asked by a large oil company to do a major security audit. The best way that we could do that, well, we really understood security audits. We didn't have the resources to go out and look at every machine on the plant floor and understand how it was connected, what its state of affairs was. So we partnered with a systems integrator in Vancouver, Canada at the time. Interestingly enough, the project, which ran out to be almost $500,000 when the dust settled, was 20% as security experts, our responsibility, and 80% for the systems integrator to do all the data collection. So excellent opportunity for systems integrators to get their toes wet by finding a highly sophisticated risk analysis partner. And I can give some names and suggestions if you're looking for some. But do all the running and all the checking and all the reviews, because that's well within your capability. The other thing, I won't go through all the steps here, but another step that I think systems integrators have a major opportunity is in what I call the implementation phase. That's where you've now understood what you're dealing with, and you're going to design an architecture and install all the protection equipment or all the monitoring equipment needed to make a control system secure. So this will include things, again, that you may not want to bite off right in the beginning, such as a zone and conduit strategy for security, and you may want to hand that off to somebody else as a partner. But certainly network architectures design and all the commissioning and all the testing and validation could be something for a systems integrator, even who is just starting into security, to be able to do. Again, you want to pick a good partner. We can recommend them. My company doesn't do these kind of audits. We're really focused on providing the equipment to make it possible to do the design and the. But we can recommend people. And again, a good example of somebody that can do this type of work who doesn't do the commissioning and doesn't want to do deployment would be a company called Exida on the East Coast in the Philadelphia area. Very experienced in doing audit work and always looking for partners. And then finally, there's what we call the maintain phase. And this is making sure that the system stays secure. This isn't a endpoint. Security now is a journey, just like safety has been. And so there'll be systems reviews, threat landscape reviews, staff upgrading, and very, very good opportunities, again, for the systems integrator wanting to get into this work is change management reviews. And for the very ambitious, there's continuous monitoring services, the ability to actually monitor and alert a client if something is going wrong with their control system. So you can see that there are phenomenal opportunities out here for the systems integrator that go along with the new responsibilities and new expectations from your client base. So I'll do a few closing thoughts, and then we'll cut to questions. Okay. Oh, I just see a really good question here. Can you spell the name of the company that you mentioned in Philadelphia that does security audits? And yes, it's Exida. And I'm not sure if everybody can see this. Oh, probably. It's spelled E-X-I-D-A. Okay. It's an international company of about 70 to 100 engineers that does safety and security work around the world. If you just Google Exida Security, you'll find them on the Internet. Okay. So I'm just going to throw in a few closing thoughts, then we'll do a few questions. So the first thing that I think it's really important for everybody to understand is that Stuxnet really changed our threat landscape by not only educating us, but unfortunately educating a world of bad guys. The control systems existed, control systems were vulnerable, and control systems would do interesting and nasty things if messed with. And so what we've happened now is that our control systems are now the target of sophisticated and unsophisticated attacks. They're definitely directed against them. We're no longer collateral targets. We're actually the target. And so what we're seeing is that in one camp is the bad guys, the other camp is the security researchers, where the security researchers are publishing all this information free for the bad guys and the good guys, but it's now giving the bad guys this capabilities. Okay, I think there's no hope we're going to be completely secure ever, any more than I can hope to never ever get the common cold. We are going to get malware. We are going to get viruses and worms and attackers getting into our plants. Now the trick is to manage them, to be able to keep them as close to the periphery as possible, to detect them as soon as they get in, to not let them spread through. And again, if you look at the standards, particularly the ISA and IEC standards, they'll talk about this zone and conduit technology. And I've got some references coming up about how to use that in your designs to make sure that when something bad does get in, it doesn't spread. And I really believe that systems integrators can play a key role. In fact, I think they'll play probably the key role going forward, and it's one of the reasons that I gave this talk. You know, we're not a systems integrator. I used to be years and years ago working for one, and I really believe that this will flop unless the systems integrator community stands up and really takes both the responsibility, but also takes advantage of the opportunities that the clients are asking for in order to make sure that control systems are secure. And we're very interested in working with any systems integrator who wants to work with us and really able to provide these services to their clients. I believe that if we don't get security down, there will be no safety and no reliability of our control systems. I truly believe that if you haven't got a secure system, you don't have a safe system and you don't have a reliable system. So a few references, which I'll leave up here on the screen, that you can basically go out onto our site and look at. If you want to contact me, I'm interested in anybody with any questions. But we've got a few minutes left, so let's open the mics and let's see if there's any other questions. While we're waiting for other questions, I've got a few questions that have been thrown into my Q&A list. And one is, do you have any software auditing tools to recommend? That's a very, very good question. Depends. If you're just strictly wanting to use software auditing on the desktop, Microsoft has some good tools, such as Microsoft Baseline Analyzer or the Microsoft Attack Surface Analyzer. These are good tools. They're free, and they're very, very useful for basically understanding the vulnerabilities on a particular platform as configured. However, they don't look at is there vulnerabilities in a piece of software? If you're going to do that, if you want to actually look inside some software and say, is this HMI designed well? Then you need another whole suite of tools known as code analyzers and software fuzzers. That's probably more than most systems integrators want to go after. And then there's other tools that are worth considering, and that is tools that really help you run audits. The U.S. government and on the ICS cert site has a tool called, CS2, I think it's called. You can't miss it anyway. On the site, I'm just forgetting what letters it is. They have an audit tool, and there's several other companies that are starting to produce audit guidance tools. One, for example, is coming out from Verizon in a little while, so there are tools out there. It is still a bit of a mixed mess as far as like a fully integrated tool. Any other questions out there? I'll just look and see if I've got any other questions here. Well, another question is, can I discuss the use of usernames and passwords for security access, changing the password, administration of access? What are the best standards to set up procedures? Wow. That is a huge question. Wow, I don't even know where to start with that. That's another whole lecture on its own. There's a number of real complexities to get thrown into this for the control systems person, because we're not just dealing with Windows boxes, and there are some very, very good policy management tools that are available if you were only working with Windows boxes. Add to those some very, very good tools, for example, like DriveLock or some of the McAfee products or some of the other products out there for actually controlling what people do with their desktops, and you stand a chance. But we get added the problem that we are not just accessing Windows boxes, we're accessing PLCs, we're accessing the RTUs, we're accessing the DCS. And then you can't be using the tools that somebody like Microsoft offers you, such as Active Directory. So I don't know where to start on that one, because it's such a big monster to bite off in a 2-minute question. I highly recommend, if you're interested in this, there's a number of good articles on our site on password management, and there's also some very, very good articles in Microsoft on the use of and design of Active Directory systems. And then also the U.S. government in their ICS cert has a number of reports. But this is where, if you're designing one for the first time, you want to get professional help for somebody like Exodo or somebody like that, because, boy, it's an interesting nightmare. Another question is, how can we get a presentation of this, a copy of this presentation? Monica, is it going to be available up on the website?
It will be on the website, but everyone who has signed up for this will also receive an email with that information.
Great, okay. And if you don't get it, you can contact me, Eric Byers, at tofinosecurity.com. I'll just write that out for all of you, or if you have any questions. And I can send it to you directly if for some reason you don't get this, the mail message from, there you go, to everybody. If you don't get the notice, or you miss the notice coming from CSIA, then just contact me and I'll make sure you get it. Any other questions out there?
Erica, just forward you one.
Okay. I've got another one here. Is there a list of command and control systems for the industrial malware discussed? Good question. The answer is yes. Government agencies keep lists of those. You need to get some sort of security clearance or some sort of security access I get the Canadian government list and I get the U.S. government list. I don't know if you don't get, and this is where you need to take advantage of working with your client because if your client is a major oil company or one of the major players, they'll have somebody with access to these lists. But there is no public list that I've seen at this time. They're generally considered a need-to-know only distribution. I don't know if that's good or bad, but that's the way it's currently set up. So the answer is yes, there is a list of indicators and command and control servers. Another question I see here is how long does a whitelist app take to baseline or calibrate the app for safe, allowed communications? Any statistics on rejected requests after a reasonable FAT? I don't have any information. Whitelisting is still a learning curve. It's still an evolving product, but I do think it's really promising. Again, I'm going to say the application whitelisting, where you're saying what applications can run on your HMIs and your plant floor computers, is one way to go. Another one is what we call network whitelisting. What we actually do for clients is we have a technique called test mode in all our products. And what that allows you to do is set up the rules that you think are right to only allow the traffic that is absolutely needed for control systems, and then run the firewall in that mode. We typically recommend at least 48 hours, ideally 1 week. And what will happen is that all the traffic will pass, but what you'll see is that you'll get alarms for traffic that would have got dropped if you were in normal operational mode, so that you can learn basically what's on the plant floor. I think that calibration stage is very important. When I was first doing firewall work 10 years ago, I remember being out at a large refinery and they laying out exactly what protocols should be on the network. I set up the firewall. I was about to press the go button. It was a standard IT firewall at the time. I was about to press the OK, use this. And then I just happened to notice, because I had a protocol analyzer hooked up, that there were other protocols on the network that they'd completely forgotten. And had I hit go, I would have shut down the plant. So I think it's very important that if you are doing your network work, particularly on live plants and brownfield plants, that you have the tools, again, test mode or something like that in your firewalls to make sure that you can basically learn what's on the network so you don't accidentally make mistakes on what should be allowed or denied. Any other questions? Okay, I don't see any more questions, and I see it's 9:03, and so we'll wrap it up for today. Again, feel free to contact me if you have further questions, either through the CSIA or through my email address, or by going to our website at tofinosecurity.com, or come and visit me when you're down in St. Petersburg at the CSIA annual meeting. Thank you very much, and have a good day.
So to all the attendees, thank you for your participation. I hope that you have several takeaways to enable you manage cybersecurity risk. And if you're an integrator, be prepared to provide cybersecurity service that your client expects. Eric, thank you very much for your contribution of your time and expertise. Your presentation was very insightful. We wish the best for you and all at Tofino Security. Keep up the good work. Thanks again to our host and sponsor, Jan Weber at Software Toolbox. Be sure to complete the survey for today's webinar. It will arrive in your inbox within the hour and takes only 30 seconds to complete. Your feedback is necessary for our continuous improvement. So in the closing, here's a bullet list to you to consider. Attend the 2013 CSIA Executive Conference in St. Petersburg, Florida. The registration link can be found at the CSIA Connected Community homepage. Attend the Stanley Sales Workshop on Wednesday, May 1st, the day before the conference. If you haven't renewed your company's due for 2013, please do it soon. one good idea for a webinar like this provides a return on your dues investments. And finally, if you have a suggested topic for a webinar, please include it in your survey comments. This is Monica Anderson. Thank you again for attending. Goodbye.